Dear students, in this video lecture, I will demonstrate you how to generate a square wave using 8051 timer. This is the question, and according to that question, we will first develop the program and then we will simulate it and observe the square wave on port P. It is being asked here that develop an assembly language program for 8051 microcontroller to generate a continuous square wave having T on equals to T off equals to 5 millisecond on P2.3 pin using timer 0 in mode 1. Assume that crystal frequency is equal to 11.0592. It means that one of the port pins of microcontroller is chosen here, which is P2.3 pin, and on P2.3 pin, if you connect an oscilloscope, then in that case you should be able to observe a square wave which is having on time as 5 millisecond and off time as 5 millisecond. For that purpose, we have to take the help of a timer. Particularly, timer 0 is to be used and it is to be used in mode 1. Mode 1 is 16-bit mode and crystal is to be used of the value 11.0592 megahertz. For this purpose, we will first develop the values, or first we will calculate the values which are to be loaded in timer register so as to generate the delay of 5 milliseconds. The on time and off time, they are of same, that is 5 milliseconds. So we will generate a delay which is equal to 5 milliseconds. We know that for timer, if it is operated in mode 1, delay can be given by a formula which is delay equals to 65,536 minus count into 12 into 1 divided by clock frequency. This part, that is 12 into 1 divided by clock frequency, is written because timer does not take clock directly from the crystal. It first divides the clock by 12. And here we are talking in terms of time. So 12 into clock frequency is taken. Ultimately, it is the time period for the timer. The count is the value which is to be calculated, and that value when loaded in timer register will give you the required amount of delay. So replace the delay with 5 milliseconds because 5 millisecond delay is to be calculated. 65,536 minus count into 12 into 1 divided by crystal frequency. In question, it was asked to use the crystal having the crystal frequency 11.0592. That's why I have written 11.0592 megahertz. When you calculate this, it is 1.085 microseconds. So this part, when it is calculated, it comes to be 1.085 microseconds. So replace it with 1.085 microseconds. And then solve this expression. Once you solve this expression, the count value comes to be 60,928 in decimal. Now convert this count value in equivalent hexadecimal value, and which comes to be EE00H. So this 16-bit hexadecimal value has the importance that when you load this 16-bit value in timer register and when you start the timer gets overflowed after 5 milliseconds. So for generation of 5 millisecond delay, you need to load timer registers with value EE00H. This is a 16-bit value. So we will require 2 registers, and those 2 registers are TL0 and TL0 because in question it was asked that use timer 0 in mode 1. So as timer 0 is to be used, TH0 is higher order register which will hold higher order 8 bits of count value, which is EE. TL0 is timer 0 lower order register which holds lower order 8 bits of count value. So once you are done with the timer values, then it's time to go through the various steps that we are going to follow before writing the program. It is as good as writing the algorithm. So algorithm is step-by-step description of the steps which you will follow in your assembly language program. Now the first step is you are using timer 0 in mode 1. And tmod is the register which helps us to configure the mode of a timer. So we should load tmod register with appropriate value, and that value can be calculated by using proper 1-0 pattern. We'll discuss it afterwards. Once you are done with deciding the mode of a timer, then it's time to load TH0 and TL0 registers with appropriate count value. We have just calculated the count value as EE00H. So in this step, TH0 is to be loaded with EEH value and TL0 register is to be loaded with 00H value, because these values will generate a delay which is equivalent to 5 milliseconds. Now it's time to start the timer. So with the help of instruction, you can start the timer 0. Once timer is started, with each incoming pulse from the timer clock, its value gets increased by 1. So value in TH0 and TL0 register gets incremented by 1 with each incoming pulse. So what we have to do? We have to check or we have to monitor timer overflow flag, which is indicated with the help of TF0 bit. So monitor TF0 flag and wait until it becomes 1. What does it mean? It means that check the status of TF0 flag. If this flag is 0, it means that timer is still ticking or it is not in overflow condition. So just wait. Again check it one more time. If again it is 0, then it means that timer is not yet overflow. So go on checking this flag or go on monitoring this flag until it becomes 1. When will it become 1? It will become 1 when timer is overflow condition. And when timer gets overflow, it means that it has generated the required amount of delay. So in other words, when timer overflows, it has generated 5 milliseconds of delay in our case. Once timer overflows, then immediately stop the timer. Immediately stop the timer. Then as timer overflow is indicated by setting of TF0 flag. So clear the TF0 flag because we have to use the timer again for T off period. So for that purpose, you have to clear the TF0 flag for next round. And then change the status of P2.3 pin because square wave is to be generated on P2.3 pin. If it is high, then make it low. If it is low, make it high. And repeat this whole procedure number of times. So how to repeat it? You have to go to step number 2 because in step number 2, TH0 and TL0 registers are loaded with initial values, that is E and 00. As we are using timer in mode 1 is not auto reload mode. That's why we have to manually load the values. So in order to load the values once again for next iteration, we have to go back to step number 2 and then same procedure is to be followed. So this will go on and on because we have to generate a square wave in continuous manner. Now let us go to the Keil IDE where we are going to develop the program. In Keil IDE, first step is you have to create a project. For that purpose, go to the project menu and click on new microvision project. I will name the project as square wave and then I will click save button. The next window is you have to select the microcontroller. I am writing program for 89C51 microcontroller. So I will click it and then I will click OK. A message pops up. Click no because we are using assembly language, so it is not necessary to copy that file. So we are done with creating a project. Next step is to create a editor window where we will type the program. For the purpose, click on file menu and click new. A new editor window gets opened. Before starting typing the program, I will advise you to save the program. So to save the program, click this save button and this window gets pops up. Name the program with the same name as given to the project. So I will name it as square wave.asm and then I will click the save button. So you are done with the saving of the program. Now next important step is to add this saved program into source group 1. For this purpose, you have to right click on source group 1 and click on add existing files to source group 1. Ensure that you are in the same folder where you have saved the program. Change the file type to ASM source file because I am going to add the program which was saved with .asm extension. Click on the name of the program, square wave, click on the add button and then click on the close. You can verify that whether it is really added or not. Yes, it's now added. Now start writing the program. The first step is start with the org directive, which will help microcontroller to understand where exactly it has to store the program. So org0000h will start storing the program in code memory from address 0000h. The first step is loading the tmod register with appropriate value. So as discussed previously, we have to load tmod with appropriate value. How to load tmod with appropriate value? For that purpose, I should know the structure of tmod. So this is the structure of tmod. Now what I will do, I will decide that which timer I am going to use. So in question, it was given that use timer 0. So as I am not using timer 1, so I will put all bits or I will make all bits of timer 1 as 0 because I am not using timer 1. So these 4 bits belong to timer 1. These remaining 4 bits are related to timer 0. I am not controlling the timer with the help of hardware way. So I will make gate as a 0. I am going to use the timer in timer mode. So in order to use the timer in timer mode for delay generation, you should make C oblique T bar bit as a 0. The next 2 bits are meant for selection of mode. So which mode I am going to use? I am going to use mode 1. So for mode 1, you have to make M1 bit as 0 and M0 bit as 1. So this is the 8-bit pattern which should be loaded in tmod register so as to configure timer 0 in mode 1. And in instruction, we usually write the values in hexadecimal. So make group of 4 binary numbers and that will be 1 hexadecimal number. So 0000h is 0 in hexadecimal, 0001 is 1 in hexadecimal. In short, 01h value is to be loaded in tmod register so as to configure timer 0 in mode 1. So let us load tmod with 01h. So this will configure timer 0 in mode 1. Next step is to load th0 register and th0 register with the values that were calculated using that formula. So th0 value is EE, but in Keil, if an alphabet comes at 10th place, then you have to write 0 before that alphabet. So instead of writing EE, I will write 0 EEH. What is the next step? Load TL0 register with lower order 8 bit. Which were the lower order 8 bits of count value? They were 00. So load TL0 with 00H. So with the help of these two instructions, what we have done? We have loaded TL0 and TH0 with EE00H value. Now, next step is to start the timer. How to start the timer? Timer can be started by making TR0 bit as 1. How to make a particular bit 1? Particular bit can be made 1 by setB instruction. Which bit is to be made 1? TR0 bit is to be made 1. So, setB TR0 instruction will start timer 0. And once timer 0 is started, it's your job to check whether overflow has occurred or not. For this purpose, I will use JNB instruction. JNB instruction will check which flag? TF0 flag. And it will jump to the label wait if that flag is 0. So what does this instruction will do? This instruction will check the status of TF0 flag and it will jump to the wait label if that flag is 0. In short, this instruction will be the instruction which will help us to wait until timer gets overflow. When timer gets overflow, this flag will become 1 and the instruction will not jump to the wait label. So where it will go? It will go to the next instruction. So as timer has overflow, we have come to the next instruction. So what is the first thing we need to do? We have to stop the timer. How to stop the timer? Make TR0 bit as 0. So timer is stopped by making TR0 bit as 0. We have started the timer by using setB TR0 instruction. Now as delay is generated, we are stopping the timer with the help of CLR instruction. Next step is to clear the TF0 flag for next iteration, because we are going to use the timer again for delay generation. For that purpose, overflow flag which was made high when is to be cleared. So clear it by using CLR TF0 instruction. Now after 5 milliseconds, what is to be done? We have to generate a square wave on which port pin? P2.3 pin. So toggle P2.3 pin. How to toggle P2.3 pin? P2.3 pin can be toggled by writing the instruction CPL P2.3. So if initially port status was high, it will remain high for 5 milliseconds and then it will get complemented. Means it will become 0. And this is to be repeated. So HJump RPT, and I will write RPT here because the new value is to be loaded in TH0 and TL0 register again. So again it will execute after 5 milliseconds. It will come here and then it will toggle the port pin one more time. So in this way the whole program works. Now let us save the program and then click on this build target. So build target will help us to find if there are any errors in our program or not. So our program contains no errors. So next step is, once you are done with compiling the assembling the program, click on this option for target button and enter the crystal frequency. What crystal frequency I am going to use? I am going to use the crystal frequency 11.0592 megahertz. Then click on use on chip ROM. Go to the output tab and click on create hex file and click the OK button. Again save the project and click the build target. Now it's time to simulate the program. You can either go into this other simulation software and simulate there. Another way is, if you want to dump this program on a hardware, on a 8051 microcontroller kit, then you have to use that kit, you have to connect that kit to the PC, and you have to observe the result by connecting a CRO to that particular port pin. But here I will use the simulation method, and I will simulate the program in the Keil itself. So that's why the first step is click on debug and then click on start stop debug session. So this window gets open. Now here what I have to do, I have to observe whether a square wave is generated on P2.3 pin or not. In order to observe a waveform, we have the facility of having a logic analyzer which works as a CRO. So for that purpose, click the view menu, and in view menu, click the analysis window and click the logic analyzer, or you can alternatively click this shortcut icon also. So this is the logic analyzer. Now just maximize it so that it is fully visible. The first setting I need to do is click on the setup and enter the pin where I want to have the waveform. So where waveform is to be observed, it is to be observed on P2.3 pin. So I have typed P2.3 pin. Select this display type as a bit, and this will be the color of the waveform. Click on the close. Now second step is debug and run. Now this you can view that the waveform is appearing. To stabilize the waveform, you can just stop the waveform. The waveform gets stopped. Now what is the grid size here? Grid size is 1 millisecond. Means between these two dotted lines, 1 millisecond is the time duration. And you can count that 1, 2, 3, 4, 5. So 5 grid lines are there. It means that this square wave is having on time of 5 milliseconds. Alternatively, you can calculate the on time by exactly placing this mouse on this falling edge. It is 12.58 second, and then subtract it with this value. So it is 12.58267. So the subtraction will give you 5 milliseconds. So you can note down these values: 12.58269 and 12.58771. So if you make the subtraction of these two values, it will come to be 5 milliseconds. So this is the on time. And what about off time? Off period, T off is from here to here. Again, you can apply the same method. This is 12.58269 and subtract this value, 12.57767. So this will again give you 5 milliseconds as a result. So thus we have checked that the obtained waveform is of 5 millisecond on time period and 5 millisecond off time period. In order to stop simulation, what we have to do? We have to click the debug button and then click on stop. And in order to come out of the simulation window, just click the debug and click on debug start stop debug session. So in this way, we have developed an assembly language program for generation of a square wave which has the on time of 5 millisecond and off time of 5 millisecond, and the output of the same program is verified by using the logic analyzer of Keil IDE. So hope you have understood this program. Thank you for watching.